Combining knowledge from architecture, engineering, science, and space exploration, space architecture is the design and construction of any habitat a human can live and work in while in space, such as on the Moon, Mars, or in orbit. This means space architects are involved in the creation of spacesuits through to lunar habitats and even the International Space Station. Space architecture is like normal architecture but with extra challenges due to the harsh environment of space, as well as the physical and mental demands of space travel. So, with support and advice from the Space Architect Technical Committee, let's find out more as I explore 10 things you should know about space architecture. 1. Space architects face unique challenges. Space architecture starts with understanding its extreme environment. On Earth, buildings deal with wind and rain. In space, you're designing for a place with no atmosphere. Without a strong gravitational force, such as that of a planet, there is nothing to hold gas and dust particles in place. Instead, these scatter throughout the vastness of space, meaning the majority of the space between stars and planets is a near-perfect vacuum. A lack of atmosphere leads to other issues. These include extreme temperatures. Without an atmosphere to shield against it, solar radiation causes extreme shifts in temperature, with surfaces in sunlight reaching hundreds of degrees Celsius and shadowed areas reaching nearly -270 degrees Celsius. Deadly radiation. Space is exposed to high levels of radiation which can be harmful to humans, so space habitats need to be able to shield occupants against this. There is a lot of research being conducted into different types of radiation shielding, from man-made materials to natural materials like mycelium. Pressure. Since space is a vacuum, there is no air pressure like there is here on Earth, so any space habitats need to provide a pressurized environment to enable humans and other organic compounds to be able to live. There is also no easy way to resupply materials in space. The environmental conditions in space demand new ways of thinking. Lightweight structures, pressurized interiors, and airtight seals are just the beginning. Imagine building a home where a tiny hole could be fatal. That's a reality space architects face. 2. Weightlessness and mobility change everything. On Earth, you feel your weight due to the normal force of the ground pushing back against the force of gravity. In a spacecraft, this normal force of gravity is absent because the astronauts in spacecraft are technically falling together. With no force of gravity to push back, furniture doesn't need legs. What about floors, walls, and ceilings? With no force of gravity pulling you down or ground pushing back against you, there's no definite up or down. This means floors, walls, and ceilings can be interchangeable. You can even sleep upside down. What is important though is that designs must help astronauts move, anchor, and orient themselves. Simple tools like handrails, foot loops, and modular panels become essential. And despite there not really being an up or down, surfaces are labelled for particular directions to help astronauts navigate their environment. On other places in the solar system, such as Mars or the Moon, there is gravity, but it is much lower than that of Earth. This means that up and down exist. However, it also means that we cannot move the same way as we do on Earth. This means space architects need to account for bouncing, reduced friction, and slower movements in these low gravity environments. 3. Pee needs recycled into clean drinking water. In space, there's no plumbing, no sewer, and no fresh air from outside. So how do astronauts get fresh air and drinking water? And what happens to their waste? That's where closed-loop systems come in. A closed-loop system is a life support system that recycles waste products into usable resources such as clean air and water. Closed-loop systems are essential for reducing the need to resupply from Earth, which costs both time and money. They also support long-duration space missions, such as going to Mars, and they result in more sustainable and self-sufficient habitats in space. There are currently different systems in place that form parts of closed-loop systems, such as the Advanced Closed-Loop System developed by Airbus for the European Space Agency, which removes carbon dioxide from the atmosphere and converts it into oxygen and water, and a urine processor assembly that extracts clean water from the urine of astronauts using a vacuum distillation process. Every drop and every breath counts. Space habitats must become miniature Earths where everything is reused, nothing wasted. 4. Life support systems need to be portable. Life support is the backbone of space architecture. It's about delivering oxygen, clean water, food, temperature control, and waste management without failure. The closed-loop systems from number 3 form part of the life support systems, but there are other things that need to be in place, including temperature control. It is essential for human and equipment health to be able to maintain a stable and comfortable temperature. Fire detection and suppression. Safety measures need to be in place to detect and extinguish any fires that may occur before they cause fatal damage to the habitat. Redundancy. This describes a series of backup systems. If one system fails, there must be another ready to take over instantly. Portability. Astronauts require portable life support systems when they are doing their EVAs or spacewalks, as they are no longer in the stable environment of the spacecraft. This needs to be able to provide the astronaut with the essentials for the duration of their spacewalk. There are different types of life support systems that are used and others being tested. Future space habitats might include plant-based oxygen generation, aquaponics, and smart AI systems to monitor human health in real time. 5. Psychology plays a major role in space architecture. Space can be isolating, claustrophobic, and mentally taxing. That's why space architecture must address mental health just as much as physical needs. Addressing these needs can reduce stress, improve morale, and strengthen performance on long-duration missions. Some things designers consider are natural light simulation. By simulating day and night time in the environment, it helps the astronaut's body regulate its natural sleep-wake cycle, which improves mood, alertness, and overall health. Private areas for personal time. When you're traveling and working in space, you are in a confined place for a long time with the same people. You can't just open the door and go home. Private areas provide a sense of personal space where astronauts can de-stress, rest, and maintain some form of normality. Communal spaces. While privacy is one important psychological consideration, so is having a communal space where a crew can sit together at the end of the day, share a meal, or socialise. Earth imagery and greenery. Visualizing Earth can help astronauts cope with the isolation and stress of living and traveling in space. It provides a sense of familiarity and improves psychological well-being. Physical comfort. From the material used to ensuring an appropriate temperature is maintained, the physical comfort of astronauts can have a major impact on their psychological well-being, since the spacecraft or habitat is where they have to both live and work. Creating a sense of comfort, control, and connection can reduce stress, improve mood, and keep astronauts mentally sharp. 6. Every inch of space matters. Space habitats are usually small, so layout design must be incredibly efficient. Space architects design modular rooms that serve multiple functions. These are standard units that can be combined to create larger structures like habitats or laboratories. They can be easily customized and offer some flexibility and efficiency for space missions. They are typically built on Earth, then transported and assembled in space. Foldaway furniture also helps maximize space, especially since the living and working environments are quite compact. By having foldaway furniture, the same room can be used for different functions, such as working, dining, or even sleeping. In addition to rooms having to be modular, an incredible amount of storage is also required. Almost every panel inside the design can be removed to allow for storage space or hidden equipment. Color-coded areas can help astronauts navigate their environment, creating distinct areas, improving spatial perception and navigation, and it helps astronauts quickly understand the purpose of different areas. Different colours can also influence emotions, and space architects can use this knowledge to create specific moods and atmospheres in different spaces. This can also help create a clear separation of work, sleep, and recreation areas. In space, a well-planned layout isn't just convenient, it's a matter of survival and sanity. 7. Safety is baked into every design. Space is unforgiving. One leak, one fire, or one micrometeoroid can be catastrophic. That's why space architects begin by identifying potential threats and weaknesses through risk assessments, identifying potential dangers. Radiation shielding, as mentioned in point 1, is an essential aspect of any design by a space architect, since exposure to harmful space radiation can result in cancer, tissue damage, and radiation sickness. Radiation shielding does not only protect astronauts, however, as equipment can also be damaged by overexposure to radiation. Fireproof materials are used to protect spacecraft and habitats from the extreme heat generated during launch, re-entry, and in the event of an onboard fire. Since an astronaut can't just open the door and escape, It is essential that materials help prevent the spread of flames, limit damage, and allow time for safe evacuation or emergency procedures to happen. Zoned compartments can also be worked into the architecture, allowing for areas of a spacecraft or habitat to be sealed off, making the rest of the environment safe to operate in until the emergency can be dealt with, or to prevent the spread of a hazard to allow for evacuation. In the event of a catastrophic emergency, emergency exits and escape pods are crucial for allowing astronauts to escape a danger while still surviving in the extreme hazards of space, meaning these will also need to be designed with a lot of the same safety considerations in mind. Habitats must act like lifeboats in the void, resilient, redundant, and secure. 8. Good design isn't just functional, it's emotional. In space, beauty can play a big role in morale. A spacecraft, or the International Space Station, is basically a cramped metal tube. Space architects adopt a human-centered design focus, making these environments in some way feel more homely and familiar. A spacecraft or habitat must be functional as well as livable. Not only is equipment for working required, but also closed-circuit systems and toilet and washing systems. By integrating these into the design, it can keep an aesthetic appeal without looking like a room full of machines. Colour choices, lighting, textures, and even shapes can all play a role in creating a space which is both functional and beautiful, making a more pleasant space for people to live and work. A great example of a human-centered design adopting both aesthetics and functionality is a spacesuit. An astronaut wearing a spacesuit, and therefore a space glove, may be required to use a computer panel. The individual keys would need to be far enough apart to account for the size of the astronaut's glove so they don't hit two keys at the same time, while also having to take into account the limited space available for a computer panel. The aesthetics and functionality of the glove and computer panel are designed to accommodate the needs of the human. As missions grow longer, personalisation and human-centred design become vital for comfort and well-being. 9. Space architecture leads the way in material science developments. The unique challenges of building in space that we have already explored often require the development of innovative materials with remarkable properties. Materials in space must be lightweight but strong, radiation resistant and temperature stable, among other things. As scientists and engineers work to develop materials that can withstand the challenges presented by space, breakthroughs are made in the development of new materials to meet these challenges. Since sending objects to space costs more the heavier they are, lightweight materials are preferable, but what if we could use materials we find on other celestial bodies that we are exploring in the solar system, or even grow ourselves? Research into using mycelium mixed with regolith found on the moon is one such example of this, providing a method for developing habitats with locally sourced and grown resources which are strong and radiation resistant and do not require heavy materials to be transported to the moon. If locally sourced or grown materials can be used for our space architectural needs, this could reduce launch costs and make large-scale building more practical. 10. Space architecture turns science fiction to science fact. The future is closer than you think, and we are entering a time when space architecture is no longer the domain of science fiction, but is science fact in the making. NASA, ESA, SpaceX, and other private companies are all exploring new frontiers. There's the aim to have lunar bases by the 2030s, followed soon after by habitats on Mars. In the long run, will we see space hotels or floating cities in orbit? Who can tell? But it seems a lot more real today than it ever has before. Today's space architects will design off-world homes, workplaces, and even the communities of tomorrow. There are two final thoughts I'd like to leave you with. 1. Space is a harsh, challenging, and unforgiving environment. However, through the incredible work of space architects working with scientists, engineers, and other STEM disciplines, human ingenuity is able to design and build sustainable environments that allow humans to continue to expand our reach into the solar system. From the vacuum of space to the dusty plains of Mars, space architecture is the key to unlocking human life beyond Earth. It's about survival, comfort, and the creative spirit that lets us build not just shelters, but futures where none existed before. 2. Space architects are like a glue that brings together different groups involved in the design and construction of space habitats, such as the client, engineers, material scientists, and even the end users. Space architecture is a field which is continually advancing, with new ideas, research and development progressing all the time. There is a lot more that curious minds can discover about materials, processes and design aesthetics to further impact the development of the field of space architecture. These developments also have an impact on architecture here on Earth, with modular design, resource management and 3D printing all finding use in construction, disaster relief and sustainable building developments. Who knows, maybe you could end up designing the habitats that humans are living in on Mars. Thank you for watching this Things You Should Know video. The information for this video came from various sources across the internet, as well as expert support from the Space Architect Technical Committee. You can subscribe to the channel by pushing the button here, and I've added a link here to my other Things You Should Know videos and underneath to my STEM activity videos and my STEM career interviews. This has been STEM with Mr. N, exploring 10 things you should know about space architecture.